Today's lesson is 10.10, probability of multiple events. So in the last section we talked about finding the probability of just doing one thing. This list, or this section, will talk about doing more than one thing. So instead of just drawing one marble, we'll draw this marble and then another marble, okay? And there's a couple different things that can affect the probability when we're doing more than one event. The events could be independent events, and this is in your book on 398. They could be independent events. And by independent, they mean that each thing that you do is not related to the previous. Okay, now I'm going to give you the Algebra Ease version that's in your book, okay? Probability of two independent events. They've got P for probability, and let's say the events are A and B. The probability of A and B would be written this way. It means that we're looking at the probability of A happening and then B happening, but they're completely independent, okay? To find that, you would take whatever the probability is of the first event, in this case A, and you're going to multiply that by the probability of the second event. Okay? So, let's say we had the marbles situation, right? Where you've got blue marbles, you've got red marbles. I think it says, with 3 red marbles, 2 blue marbles, composing a jar of 5 marbles. If we wanted to find the probability of the red marble and the blue marble if we put the marble back in. So we draw one marble out and then putting it back in, probability of getting the next marble out, okay? So they've got this written this way for that example. They have the probability of red, so this is our example, the probability of red and blue, okay? And in this case, there were 5 marbles in the jar. 3 of them were red. So the probability of drawing the red marble would be 3 out of 5. Okay, or a 3 in 5 probability. You would first draw the marble and then put it back in. So the next one, probability for drawing a blue, there are 2 blue in the jar, but because you put the first marble back in, there are still 5 marbles in the jar. Okay, so you drew the first marble, put it back in, drew the next marble. The probability of this happening would be 3 times 2 is 6, and 5 times 5 is 25. So the probability of this happening would be a 6 in 25 chance, or 6 25ths probability. I shouldn't say chance. Take that out of your context there. I shouldn't say it that way, okay? So it's just, the probability is 6 in 25. And then the decimal version, if they ask you for the decimal, we just know 6 divided by 25. Rounded to the nearest hundredth, 0.24 probability. Okay? So, pretty straightforward. Again, they'll have to tell you that you're replacing the marble. So, I'll just read the example for 10.10a. It says a bag containing 3 green marbles, 2 red marbles, and 1 blue marble. When 2 marbles are taken from the container at random, what is the probability of selecting 1 red marble and 1 green marble when the first is replaced before the second is removed? So they're going to say it just like that. If they want you to do it this way, where the same number of marbles are there for each time, they're going to have to tell you that it's been put back in the bag, that it's been replaced. Okay? So that is independent events where the marble or the event is being put back in, meaning they are completely independent of each other. Let's look at dependent. So dependent events are where the first event affects the second event. That's a dependent event. And our dependent event, your book has it as probability of two events without replacement. So we'll put dependent event in parentheses, no replacement. Alright. And the algebra version of this, they write it this way. We'll have the probability of event A and event B, looks the same as the last one. The difference is, when we get ready to solve it, we're going to show the probability of the first event, like normal. But if we're not going to replace the marble back in for the other example, now we have fewer marbles to choose from. So if there had been 5 marbles in that first drawing, then the second time you draw, now you only have 4 to choose from. Okay? So after the original event happens, the second event has been impacted by the first. So it'll be the probability of B given A. Okay? This does not mean divide. A little slash is just a little symbol that means given A. Like you've already taken into account that A has happened. So it's just a way of notating that. Okay? So let's take a look at the example 10.10b. And it says, consider a bag of marbles having 3 green, 2 red, and 1 blue. What is the probability of selecting both red marbles when the first is not replaced before the second is removed? So again, they're going to explicitly tell you that there's not a replacement, and you know you're going to have less in that second time you draw. So here we go. They told us there were 3 green, 2 red, 1 blue. So 3 plus 2 plus 1 gives us a total of 6. So the probability of drawing a red marble just by itself, we know is going to be 2 out of 6. 2 of the 6 here. Which we can reduce, would be 1/3. Okay? So the probability of drawing a red marble is 1/3. Now, the probability of drawing a red after you've already drawn a red, they're using that straight line. Probability of red given you've already drawn a red. Well now, how many red marbles are left in the bag? If there were only 2 to start with, now you got 1 left. And you had 6 marbles total at the beginning, and now you only have 5. So the probability of drawing a red again is now 1 in 5. Okay? So we're going to put these 2 probabilities together to find out probability of doing this and this. So now we'll say the probability of drawing red, given you've already drawn the red, the probability of red and red, that says and. Red and red is going to equal our first, which we reduced to 1/3, times the second, which is 1/5. So 1/3 times 1/5 gives us a probability of 1/15. If they wanted the decimal, take 1 divided by 15, round it to 2 places, and it's 0.07. Okay? So you just have to listen carefully to the question. If it says they've replaced the item back, then you know you're going to keep the denominator in situations the same. Total number of that color, total number in the jar the same. But if they say no replacement, you have to take that into account, you know, the color and then how many total there are. And then you'll multiply those together. Alright, so this should be enough to get us going. And we'll work on the assignment.